graphs that we're looking at. So we have looked at distance versus time graphs. We saw one speed versus time graph on that drone thing. We've not looked at any acceleration graphs. But here we've got distance versus time. We've got velocity versus time, which is going to be the same as any speed, and acceleration. What does the slope of a distance versus time graph tell us? Slope is always rise over run, right? It's change in y over change in x. Well, on a distance versus time graph, if slope is a change in y over change in x, well, y is distance and the x is time. What's distance divided by time? Is your speed or your velocity. I'm going to put velocity there since that's how that's labeled, the next one. Remember that as long as we've got things going in a straight line in one direction, which are most of our practice problems, our speed and velocity is the same. What about a velocity versus time graph? If slope is rise over run, or change in y over change in x, what's the y on a velocity graph? It's velocity. So change in velocity over change in x, what's our x? It's time. What is change in velocity over how much time that takes? That's acceleration. Which means whatever the slope of a distance graph is going to tell us our our velocity. And whatever the slope of a velocity graph is going to tell us our acceleration. So each one of these is going to inform the next. You could also kind of work backwards too. But we can take one story of motion, like the one from our bell work today, where a bird was flying and saw a branch, it started to slow down, and then it landed on the branch. 3 different graphs can show that motion. 3 different graphs can show that motion, whether it's a distance graph, a velocity graph, or an acceleration graph. So we're going to practice a couple of these. I'm going to use some highlighters because it's pretty, mostly. So first one, if we have constant velocity, so something is moving at a constant velocity, what does the line look like on a distance graph? Or do we want to skip to the middle? If something has a constant velocity, it's moving at a constant speed or velocity, is its speed or velocity changing? No. So whatever it's at, it's going to stay there. So let's say our speed or velocity is 3. If it's at a constant speed or velocity, it's going to stay at 3. But then let's go backwards. What's the slope look like on a distance graph for something that has constant velocity? If the velocity is constant and slope of a distance graph is velocity, what does that mean about the slope? It's going to be constant. Well, constant slope looks like a straight line. So if the slope is constant, it's a straight line, that's because the velocity isn't changing, or the speed isn't changing. Well, we see that right here, that the velocity or speed isn't changing. What's the slope of this line right here? What is it? 0. Well, if the velocity isn't changing, so the slope is 0, if velocity isn't changing, change in velocity is 0, what's the acceleration? 0. So then the acceleration is going to be 0. I'm going to add a couple notes on here. So if the velocity is constant, that means that the slope is constant. Well, if the slope is constant because it's moving at a constant velocity, well, then the velocity isn't changing. And if the velocity isn't changing, well, then the slope of this one is 0. It's a flat line because the velocity is staying the same, which means the acceleration is going to be 0 because the velocity is not changing. You want to pick another color? Anybody care?
Orange.
Got it. Okay. Okay, next one. What if something is speeding up? If something's speeding up, it's getting faster. Well, on a distance graph, if it's speeding up, if it's getting faster, then the slope has to be getting greater. The line has to be getting steeper. So what does that look like? Can you show me with your arm before you, like it's going to start slower, and then it's going to get steeper, 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 steeper. So what does that look like? Looks like starts slower, gets steeper, steeper, steeper. Gets shallow, starts shallow, gets steeper, steeper. Starts with a lesser slope, and the slope gets greater, greater, greater. What is that going to look like on a velocity graph? Well, if the velocity is increasing, it might start at 0 and then be at 1 and then 2 and then 3. So that's going to look like the velocity is increasing. So what do we see here? We see that slope is increasing. It's getting steeper. Here we see it slope is constant even though the velocity is increasing. The velocity is increasing. We went from 0 to 1 to 2 to 3 to 4. But the line is straight, the slope is constant. What does the slope of a velocity graph tell us? Slope of a velocity graph, how much velocity changes, is the acceleration. So if the slope is constant, that means the acceleration is going to be constant. Is the slope here positive or negative or 0? It's positive, right? So our acceleration is just going to be something flat. Acceleration is going to be something constant and positive. We're going to keep our acceleration graphs really simple. Our acceleration graphs are all, in 9th grade, all of our acceleration graphs are going to be flat. And they're going to be either positive, 0, or negative. If the acceleration graph is positive, that means the speed is increasing. If the acceleration graph is 0, that means the speed is not changing. There's 0 acceleration, there's 0 change in speed or velocity. What does it mean if the acceleration is negative? It's slowing down. It's slowing down. Okay, let's flip it over. Anybody want to choose another color? Which color? Pink? Okay. Okay, now we have slowing down, decreasing velocity. So this was our Bellwork one, our Bellwork example. So we're going to start with something faster, meaning the speed is steeper, the slope is steeper. And then what's going to happen to that slope? It's going to get shallower, shallower, shallower. So we're going to see it's starting steeper, but it's getting less steep. Slope starts great and is getting less and less and less, which means speed is starting greater and getting less and less and less. So what do we see? We see that the slope is decreasing. It's getting less steep, which means what's happening to our velocity? Our velocity is also decreasing. So our velocity is starting something faster up here, but it's getting less and less and less. So maybe it starts at, what would it be, like 5? Velocity starts at 5, and then it's 4, and then it's 3, and then it's 2, and then it's 1, until, in this case, we'd put it all the way down to 0. Okay, what does that look like then in an acceleration graph? First of all, is this line straight? Or at least it's intended to be, however carefully I drew it. What's the slope, positive or negative? Negative. Which means the acceleration is going to be negative, meaning it's slowing down. Negative acceleration means it's slowing down. All right, the next couple have different segments to them, like different parts of the story. So I'm going to look at that, and I'm going to actually divide up my graph in that way. Next one, it says slowing down, then stopping. So I've got 2 parts to this motion. So I'm going to divide my graph into 2 parts, just so I can really clearly see what's what. I'm going to do that so all of my graphs match. Because remember, all 3 of these graphs are showing the same thing, the same motion or the same story. Should we do purple and blue? Okay. Okay, so first we're slowing down. Then we're stopped. So if we're first slowing down, I'm going to do that part in blue. First we're slowing down. What does that look like if I'm slowing down on a distance graph? Well, just like this one up here. Starting steeper, but my slope is getting less and less and less. What does that look like on a velocity graph? My velocity is decreasing. I'm starting with a higher velocity, but over time my velocity is decreasing. What does that look like on an acceleration graph? Well, if I'm slowing down, my slope on the velocity graph is negative, which means my acceleration is negative. So far, this first part of the motion, doesn't that match exactly what we did up above? Yeah. Okay, what about stopped? If I'm stopped, is my position changing? My position isn't changing. My distance isn't changing. What would the slope be? Well, okay, maybe let's go here first. What's my speed or my velocity if I'm not moving? 0. So that better be 0. My velocity here is 0. That means my slope on my distance has to also be 0. What does that look like? Looks like a flat line where my distance or my position is not changing. If I'm not moving, what's my acceleration? 0. What's the slope of this line right here? 0. I'm going to add a quick note on that since we haven't seen that yet on one of these graphs. So if I'm stopped, that means my position isn't changing. That means the slope here also has to be 0. And if I'm stopped, that means my velocity is 0. Okay, look at the next one. Next one, slowing down, then stopping, then speeding up. This one actually has 3 parts to it. So I'm going to divide my graphs into 3 parts, so I can see those 3 separate parts of the motion. Okay, my graph is ready for 3 parts of my motion. First one, slowing down. If I'm slowing down, what does that look like on my distance graph? It looks like my slope is decreasing. So starting steeper, but getting shallower. Slope is decreasing. What does that look like on my velocity graph? Well, I'm starting with if I'm slowing down, I've got to start with some greater velocity, some greater speed. It was going faster, but then my velocity is decreasing. And if I'm slowing down, my acceleration is going to be negative. I'll do orange next. Next part, I'm stopped. Slowing down, then stopped. If I'm stopped, my position is not changing. My distance is not changing. If I'm stopped, my velocity is 0. If I'm stopped and my velocity is 0, well then my velocity isn't changing. My acceleration is 0. And then, what if I'm speeding up again? I was stopped, but now I'm going to speed up. So I'm speeding up. Right now my slope, when I was stopped, my slope was 0, which means my speed is 0, which means now I need to start getting faster. My speed is increasing on a distance graph. That means my slope is increasing, so it's going to get steeper. I was stopped, but now I'm going to speed up. So if I was stopped, my velocity was at 0, but now it's going to increase. It's going to get greater than 0. It's going to be 0, then 1, then 2, then 3. And if I'm speeding up, I'm getting faster, my velocity is increasing, well, then my acceleration is going to be positive. Okay, last one. It says speeding up, then staying at a constant velocity, then slowing down. So this one also has 3 parts to it. So setting up my graph so that I can really clearly see what's each part of that 3 parts. All right, speeding up first. If I'm speeding up, what's happening to my slope on my distance graph? Well, it means my slope has to be getting greater, my speed's getting greater. So I'm starting shallow, but I'm getting steeper. That's a curve. Is that clearly a curve? If I'm speeding up, that means my velocity is increasing. If I'm speeding up, what's my acceleration? Positive. Sorry, that's flat. Okay, then staying at a constant velocity. If I'm staying at a constant velocity, maybe I'm going to skip to here first. I'll do this middle one first. If I'm staying at a constant velocity, that means my velocity is not changing. My velocity is not changing and I'm at 3 right now, then it's going to stay at 3. Well, if my line's flat right here, my velocity isn't changing. That means my speed isn't changing. That means my slope on my distance graph isn't changing. So this one needs to be a straight line. And we can compare that all the way back to the first one that we did of constant velocity. If it's constant velocity, then the distance graph, the slope has to be constant, straight line, which means the velocity is constant, it's not changing. What's the acceleration if your velocity is not changing? 0. So my velocity isn't changing, my acceleration is 0. Last part then I'm slowing down. If I'm slowing down on my distance graph, my slope has to start decreasing. Speed is decreasing, so that looks like it's getting shallower. On the velocity graph, I'm slowing down, my velocity is decreasing. If my velocity is decreasing, that means my acceleration is negative. Okay.